understanding arrow notation with rational functions. So looking at this, we have a couple rational functions given to us, the 1 over x graph and the 1 over x squared graph. Let's take a look at the 1 over x graph first and talk about what's going on. We have two different types of asymptotes going on here. We have a horizontal asymptote going at the x-axis, or when y is equal to 0. And you can identify this because way off on the right-hand side and way off on the left-hand side, we're getting closer and closer to the x-axis. This is sometimes referred to as end behavior, and we can say as our x values go way off to the left-hand side, so that's as x approaches negative infinity, way out here for x values, our y values, or f of x values, get very close to the x-axis, or that's a y value as 0. We could say the same thing is going on at the right-hand side. As our x values approach positive infinity, as we go way off to the right-hand side for x values, our y values, again, approach 0, or the x-axis. Okay, so that takes care of our end behavior, or long-run behavior, and a horizontal asymptote. We have another vertical asymptote going on at the y-axis for this graph. So the notation looks a little bit different on this one. We can say as x approaches 0, or gets very close to 0, from the right-hand side, we're going to use the superscript of a plus. What that means is as I approach on top of this graph, as I get closer and closer to an x value of 0, walking on top of the graph from the right-hand side with the plus, our y values seem to go up towards infinity. So we can say our y values approach infinity. We can also say on the left-hand side, as our x values approach 0 from the left-hand side, so using the superscript of a negative, that means that as we walk on top of this graph, getting close to 0 for an x value, so we approach closer and closer to 0, our y values tend to go down forever. So we'd say the y values approach negative infinity. Basically, wherever you see the arrow, we're going to say approach instead of an arrow. Now let's take a look at our 1 over x squared graph. Similarly, on this one, we can say as our x values approach negative infinity, so that means as we go way off to the left-hand side, we look at where our y values go. We say our y values, again, get close to 0, or the x-axis. The same is going to be true on the right-hand side, but this time you use as x approaches infinity. Our y values, again, get close to 0, this time from above. Just like over here, we're getting closer and closer to 0 from above. As our x values approach 0 from the left-hand side here, we can say our y values, as we get closer and closer to 0 for an x value, walking on top of the graph from the left-hand side, our y values are going to continue to go up. So we'd say go to infinity. And as our x values approach 0 from the right-hand side, our y values also go up. So walking on top of the graph this direction, our y values continue to increase without bound. We say they go to infinity. Down below here, you can see our symbols and our notation. Approaching from the left-hand side, approaching from the right-hand side, going to the right for a very long ways to infinity, going to the left to infinity. And then looking at what happens with our y values, either they go up, they go down, or they approach some specific value, just like they approach 0 in the above examples. Next up, we have vertical asymptotes. These occur when your x value gets close to a specific value and either your y values go up, or you get close to that x value and your y values go down. So that's where your y values either go up or they go down when you get close to a vertical asymptote. Next up, our end behavior, or sometimes this is referred to as long-run behavior. It's what happens at the extremes, like way off to the right-hand side or way off to the left-hand side. Sometimes we have these horizontal asymptotes, whereas our x values get big in the positive sense or in the negative sense, our y values are going to approach a specific number. Let's use one more example here and describe the end behavior and the local behavior. The local behavior being vertical asymptotes. So they're designated this time because they're not on the axes with dashed lines. So we have a horizontal line going across here. That's going to be a horizontal asymptote and a vertical asymptote going, it looks like at 3. So in this case, we can say as our x values go to negative infinity, what we're looking at there is as we go off to the left-hand side, it looks like our y values are getting closer to the horizontal green dashed line. So we can say our y values approach 4. We can also say as our x values go to positive infinity, as we go way off to the right-hand side, our y values, or f of x values, again are getting closer to that horizontal dashed green line at 4. Finally, our vertical asymptote, we can say we're approaching 2. So we can look at as our x values get close to 2, but from the right-hand side, meaning from the right-hand side over here as we walk on top of this graph, looks like it goes up. So we can say our y values go to infinity. And we can also say as our x values approach 2 from the left-hand side, our y values seem to go down. So negative infinity is down for our y values down this direction. We would label these as we have a horizontal asymptote. Is going to be at a y value of 4. And we have a vertical asymptote at an x value of 2. These vertical and horizontal asymptotes are going to be equations of lines, so make sure you do include y equals 4 when it's going to be a horizontal line going across at 4, and x equals 2 and it's a vertical line where all these x values on this vertical line have an x value of 2. All right, hope this helps out with arrow notation. I know it's confusing the first time you see it, but it's really not that bad as long as you pay attention to what you're actually looking for.